Hello, good morning to you all. And how was your weekend? How was the night? It's amazing having you online again. And I trust you're going to enjoy this video. Please just sit, relax yourself, watch the video again and again, and please help be sure that you understand every concept explained. In case you have any question at the end of the video, please just put your question underneath the comment section, and I'll try my possible best to give all possible answers. Thank you. Sit back and enjoy the video. All right, so this is the second lecture on geometry, and today our focus is going to be on congruent triangles. Congruent triangles. Here are the objectives. At the end of this lesson, learners should be able to 1. Recall and apply the conditions for triangles to be congruent. That is, 2 sides and the included angle, 2 angles and a corresponding side, 3 sides, right angled, hypotenuse, and side. 2. Learners should also be able to use the elementary theorems and properties of congruent triangles to prove theorems and riders. 3. You should be able to identify properties of isosceles and equilateral triangles. So these are terminologies I believe you've seen in the last video, and symbols that you are also going to use, which you have also seen in the previous video. Congruent triangles. So what are congruent triangles? I believe you've been hearing the word congruent. What is the meaning of congruent triangles? Definition. 2 shapes are said to be congruent if they have exactly the same size and shape. For instance, the 2 triangles below are congruent, although they may appear different, but if investigated properly, you find out that they have equal length of sides and angles. So I believe you understand the meaning of congruency. It's as simple as that. When you say 2 shapes are congruent, it means they have same size and same shape. They are equal, that is what it means. So, but because this is shape, we don't want to use the word equal, we use equivalent or congruent. Conditions for congruency. Condition 1. 2 sides and the included angle, which is known as SAS. S stands for side, A stands for included angle, and S stands for other side. So 2 triangles are congruent if 2 sides and the included angle of one are respectively equal to 2 sides and the included angle of the other. So these are 2 triangles, ABC and DEF. From the figures above, observe that length AB is equal to length DE. Length BC is equal to length EF, and angle ABC is equal to angle DEF. Therefore, we can conclude that triangle ABC is congruent to triangle DEF. This indicator or indication, this dash, single dash here and single dash, it means these lengths are equal. The double dash here and this double dash means these lengths are also equal. This given angle here is equal to this angle. Now please take note of something. When we say included angles, we mean the angle that is formed between the 2 equal corresponding sides. If the angle given is the angle at point A, vertex A, and the angle at vertex D, though that angle is not sufficient enough, the angle at these 2 other sides that are equal is not sufficient enough to say that they are congruent. Before congruency in this particular condition hold true, it must be the included angle, meaning that the angle must be in between the 2 equal lengths. The 2 equal lengths. So the angle at D is not included, The angle at F is not also included. The angle at C is not included. The one at A is not also included. So included angle means the angle between the two equal corresponding length of sides. Please, is that taken? All right. Next condition. This condition is known as two angles and a corresponding side, ASA. Two triangles are congruent if two angles and a side of one are respectively equal to two angles and the corresponding side of the other. So here are two other triangles again. Triangle XYZ and triangle LMN. In this particular case, length YZ is equal to MN. Angle XYZ is equal to angle LMN. Also, angle XZY is equal to angle LNN. Therefore, we can conclude that triangle XYZ is congruent to triangle LMN. So this is two angles and one side. Two angles and one side. This is known as ASA. Condition 3, three sides. Two triangles are congruent if the three sides of one are respectively equal to the three sides of the other. Now here are other two triangles, PQR and UVW. If you observe carefully, length PQ is equal to length UV, length PR is equal to length UW, length QR is equal to length VW. Therefore, we can conclude that triangle PQR is congruent to triangle UVW. So this condition is known as SSS, three sides. Next, finally, this is the last but not the least. Right-angled hypotenuse and side is known, this is RHS. Two triangles are congruent if they are right-angled, first condition, and have the hypotenuse and the side and one other side of one respectively equal to the hypotenuse and other side to be on the other side of the other. Okay, that is first, the two triangles in question must be right angled. This first condition is satisfied. You can see one of the interior angles is 90 degrees. Second, length IK is equal to PR. Condition 2 is met. Length JK is equal to QR. Condition 3 is also met. So we can conclude that these two triangles are congruent. Okay, so those are the four conditions of congruency. Can we recall those conditions again? What's condition 1? Correct. SAS, two sides and an included angle. Condition 2, very, very correct. ASA, two angles and one side. Condition 3, perfect. SSS, three sides. And finally, condition 4, RHS, right angle, hypotenuse, and side. Well, you guys are very, very amazing and intelligent. Okay, this is the final thing. Are you expected to attempt these exercises from your textbook, New General Mathematics for Senior Secondary School, Book 1, page 34, exercise 2B, number 1 to J. So please attempt this and start posting your exercises or solutions before the end of the class. Do have a nice time as you keep learning.